Hey y'all, let's cover lesson 9, multiplication and division of integers. Just to let you know, this is on a playlist for our class. So if you want to receive notices of me uploading the videos before posting them to our class, all you have to do is subscribe to that playlist, our MAT 0530 playlist, and you will know as soon as the new video is uploaded. So then you can go just hop on and start whenever you're wanting, because I know some of you are getting very antsy and waiting for these videos. So help yourself is just subscribe. All right, so as with addition, now we're doing multiplication and division of integers. We've already done addition and subtraction. As with addition, it is true that the properties of multiplication of whole numbers are also true for the integers. Okay, so a times b for the commutative property of multiplication, a times b is equal to b times a. So I can just take any integer, -2 times, let's go 3, is the same thing as 3 times -2. -2 times 3 is going to give us, well, a negative times a positive, which we'll get to that, but just to kind of glaze over this, we'll come back to it. I'll prove it here in a minute. So the other one is associative property, and it's a times b in parentheses times c is equal to a times b times c. All right. Again, I'll show you another example of that when we get there. Multiplicative identity is 1 for multiplication. So that's a times 1 is equal to a. An example would be just taking -3 times 1. That is -3. Any number times 1 is that number, is itself. Okay. Distributive property. So this is something really neat. If you have a parentheses b plus c, okay, that is equal to a times b plus a times c. Whenever I'm explaining this, you're going to see me drawing arrows to both of these terms, because even in my college algebra and trigonometry class, they're still struggling with this distributive property that you are learning about right now. Okay, so what else do I need to do here? Got the distributive. Let's go to multiplicative property of 0, and that's just a times 0 is equal to 0. Anything times 0 is just, in fact, 0. All right. Then multiplying by -1. So -1 times a is just negative a. So if you have -1 times 2, that is -2. Okay. All right. There's a lot of math happening in the background of what follows. And anyone who wishes to know more about the why is encouraged to ask me. Read the section in the textbook or consult a reliable internet source. I can always recommend Khan Academy. That's always my favorite. All right, multiplying integers. If both of the terms have the same sign, doesn't matter what the sign is, it could be positive or negative. If they have the same sign, then their multiplicative product just means multiplication. Product means multiplication. We're going to want to know that for our word problems. Make sure you know that the product is defined as multiplication. So if when you're multiplying two numbers with the same sign, their multiplication is positive. Their product is positive. All right. If the factors have different signs, one's positive and one's negative, well, then the product, the multiplication between the two, is negative. All right. So let's do a couple of examples. We're going to find the following products. The first thing I want to do with each one of these is just to go over what I just did. But at first, I'm going to go ahead and just multiply the 3 times 2. 3 times 2 is 6. All right. 4 times 10 is 40. 12 times 3 is 36. Okay. I just wanted to get that out of the way because you know how to do that. What I need you to understand is these two terms have the same sign. Because they have the same sign, the 6 has to be positive. Okay. These two have different signs. This one's positive and this one's negative. If it even helps you to put it over it, whatever it takes for you to get this. A positive times a negative is a negative. Okay. Positive times a negative is a negative. If you have 3 times 2, same signs, so it's positive. All right. What about a negative times a positive? So if we have a negative 2 times positive 3, 2 times 3 is 6, negative times a positive is a negative. Okay. If they're the same sign, they're positive. If they're different signs, they're negative. The answers are negative. Okay. So note the use of parentheses in these examples. So parentheses are serving two purposes here. One, in this case, let's see where it can do this. The negatives, having the negatives in together in parentheses, just lets you keep in mind that that is -3 and -2. This could have also have been written as -3 times -2. And in that case, the parentheses for this is representing multiplication. All right, that you have to have at least one parentheses here to represent that this is going to be multiplied. But because this one's a negative, it's just cleaner to keep it in a parenthesis. Okay. Same thing with this one. We could have just had 4 parentheses -10. In this case, the parentheses serving two purposes. One is keeping our negative isolated, and 2 is letting us know, because there's nothing in between that 4 and that parenthesis, that those two numbers need to be multiplied. Okay. When something is right up against the parenthesis, it has to be multiplied. Okay. All right, let's move on. So serves two purposes. Indicating multiplication, which is what I just described, and identifying negatives. All right. The last one says, how do we know these parentheses indicate multiplication? I think I just described it, but I think the better way to say it is there's no operator. There's no operator, which means, let me move this up a little bit. There's no plus sign, subtraction sign, or division sign. It's okay to have a multiplication sign, but there's none of the other operators between them. Okay. All right, that's it for that piece. Let's go to the second page for lesson 9 and the last page for lesson 9. All right, just to let y'all know, oh no, they're not making an announcement because it's a different class. -3 times 2 times -4 times -2. Okay, well, with PEMDAS, the order of operations, PEMDAS, arrows, okay, we're dealing with multiplication for every stinking one of these. And multiplication has to be handled from left to right. So please, even if we could mix them up, which we can, just get in the habit of always working left to right for multiplication, just to save you headache later. So I'm going to take the -3 times 2. 3 times 2 is 6. We've got a negative and a positive. A negative and a positive gives us a negative. And then I'm going to bring down the other two. All right. -6 times -4. 6 times 4 is 24. Negative times a negative, they're the same sign, so it's positive. All right, 24 times 2 is 48. And then we've got a positive and a negative, so that makes the answer negative. All right. Simplify the following. All right, so we want you to recall something here. I want you to remember that 2 to the 4th is 2 times 2 times 2 times 2. We need to remember that before we do this next piece. Okay. So this is where, again, even my college algebra students are struggling with this. All right. So just to give y'all a heads up, -2 is in the parentheses and it is cubed. So that means we have -2 times -2 times -2. -2 times -2, well, 2 times 2 is 4. The signs are the same, so it's positive. The next one, 4 times 2 is 8. We've got a positive and a negative, so therefore we have a negative. The signs are different, so it's negative. All right, let's go to the next one. -3 raised to the 4th power. So that's -3 times -3 times -3 times -3. This is not meant to go into your calculator. The reason it's not meant to go into your calculator for any of this, of what we're doing on these lessons, is because if you don't understand the concepts without the calculator, it's going to only hurt you as you get further down in this class, and especially in the next class that you'd be going to. So while you're working through this, you really shouldn't even be using a calculator as you're learning it. But once you've learned it, totally cool with you using a calculator. You just need to learn it first. So as you're working through all the homework, and even with me, work through it. All right. So we've got 3 times 3 is 9. The signs are the same, so it's positive. I'm going to bring the other two down. 9 times 3 is 27. We've got a positive and negative, so therefore it's a negative. Bring the other 3 down. 27 times 3, 3 times 7 is 21, so 6, that'd be 7, 81. We got a negative and a negative. The signs are the same, so therefore it is a positive. Okay. This next one is what hurts most students, because they think that negative is with that 3 to the 4th, and it is not. It is not. This negative is just a -1 times 3 to the 4th. So because it is not, the negative is not included in the parenthesis, in a parenthesis and raised to the 4th, it is not being raised to the 4th. Okay. Because if you put this in the calculator, it's going to show you, if you just put in -3 to the 4th, you're going to get exactly what I'm about to get. So I'm going to pull that negative out. All right. And then I've got 3 times 3 times 3, because there's 4 of them. All right. I'm going to bring my negative down. 3 times 3 is 9. They're the same sign, so positive. Okay. I'm just going to deal with everything on the right. And then bring the other two down. 9 times 3 is 27. I'm just bring that negative down. Okay, brought the other one. Now 27 times 3 is 81, but we have to bring that negative down. So our final answer is -81. Okay. There's other ways we could have done this as well. We could have brought the negative in there somewhere, but for accurate purposes of how this should be handled, what I just did would be accurate to where you don't mess up with your negative, okay? Because it is not part of the being raised to the 4th power. All right. Dividing integers. So if the dividend and divisor have the same sign, so if the top and the bottom, or the numerator and the denominator, have the same sign, both are positive or both are negative, then the quotient, and again, this is understanding word terms for math, quotient means divide. So make sure that you have that written down in your vocabulary, that quotient means divide. The quotient of fractions with the same sign is positive, same as it is for multiplication. When they're the same sign, it's positive, no matter whether it's negative or positive. They have to both be positive or both be negative to be positive. If the dividend and divisor have opposite signs, so one is positive and one is negative, then the quotient, the dividing, is negative, just like in multiplication. All right, division by 0. So A divided by 0 is undefined. I asked this question in my college algebra class just yesterday, and they did not know. So 6 divided by 0 is, well, we don't know. there's no solution here, because that would be saying that 6 is divided by 0, or saying that 6 would equal 0, I guess, and that's not possible. So yeah, this is undefined, undefined. In MyOpenMath, you're going to use DNE, does not exist. Okay, I don't mind if you use does not exist for your exams as well. All right. Simplify the following. -12 divided by -4. Okay. So that's what? -12 divided by -4. I just like to rewrite it like that. That's how I learned it. 12 divided by 4 is 3. A negative divided by a negative, the signs are the same, so it's positive. Okay. 6 divided by -3. 6 divided by 3 is 2. Got a positive and a negative, so it's a negative. Does it matter where the negative is? Nope. Does it matter where the positive is? Nope. All that matters is one's positive and one's negative. So that's what happens. The next one is -15 divided by 0. Well, this is just undefined, or DNE. Okay. Because it just doesn't work. Please remember, we have talked about 0 divided by a number, and that is 0. We have mentioned this before. So I'll just keep anything with 0 on top we can do. It's 0. 0 on the denominator we cannot do. So it has to be undefined. All right, that's it for lesson 9. Please let me know what questions you have. Get your homework done, and I'll see you in the next video.